Welcome to the WION podcast. Today on the deep dive, we're asking, well, maybe the biggest question there is, why are we here? Why does anything exist at all?
It's fundamental, isn't it? For ages, it was more philosophy, maybe mysticism, but now science is really digging into it.
Right, we have the Big Bang Theory, which gives us a kind of how the universe started expanding. But the why, there's anything, stars, planets, us, instead of just, nothing. That's still the puzzle.
Exactly. And a huge piece of that puzzle is the matter-antimatter problem. The theory says the Big Bang should have made equal amounts of both.
And they should have just annihilated each other, right?
Yeah.
Matter meets antimatter, boom, gone. Pure energy left behind.
Precisely. But, well, look around. We're here. Matter clearly survived.
So something must have tipped the scales.
Yeah.
And finding that something is what scientists are working on right now.
Yeah, with some pretty incredible experiments. There are actually two massive international teams tackling this. Take the U.S.-led one, DU, the Deep Underground Neutrino Experiment.
Okay, GPU. What do they do?
Well, first, imagine 1,400 scientists from, 35 countries. They're building these enormous detectors way down, 1,500 meters underground in South Dakota.
Whoa, that deep. Why so far down?
To get away from all the background noise, cosmic rays, radiation, that sort of thing, they need pristine conditions.
Yeah.
Dr. Jarrett Hayes called the caverns they're excavating cathedrals to science. Gives you a sense of the scale.
Cathedrals to science. I like that. So what are they looking for in these cathedrals?
Tiny, tiny particles called neutrinos. And their antimatter counterparts, anti-neutrinos, they're actually going to shoot beams of neutrinos and anti-neutrinos all the way from Illinois.
Illinois to South Dakota. That's, what, nearly 1,300 kilometers?
A long trip for a subatomic particle. The idea is to see if the neutrinos change or oscillate during the journey.
Okay.
And crucially, to see if the antineutrinos change in exactly the same way, or if there's a difference.
Ah, I see. So neutrinos and antineutrinos change differently?
That difference, that asymmetry, could be the key. It might hint at why matter and antimatter didn't perfectly cancel out right at the beginning, why we ended up with a universe full of matter.
Fascinating. And you mentioned another team.
Yes, over in Japan, they're building Hyper K. It's an upgrade, a bigger, better version of their already famous Super K detector.
Hyper K. Are they doing something similar?
Similar goal, slightly different approach to the detector. They're making these shining golden globes for it, apparently. And they might actually start firing their neutrino beams in the next few years, maybe even before DUNE is fully operational.
So it's kind of a race.
In a friendly way, perhaps. But
Okay.
really, both teams are after the same thing: fundamental knowledge. Understanding why the universe is the way it is, why existence itself happened. Who gets there first is less important than actually getting the answer.
It's pretty amazing. Huge experiments, thousands of people, all focused on this one profound question about our own existence. The quest definitely continues. Stay tuned for more such intriguing stories to come on the WION podcast.